Assalamualaikum and very good night. Okay, now 11:17 p.m. Today we continue with our lecture on EMD112 conceptual design and CAD. Okay, so today will be our first class. Okay, and first time we meet, maybe the student that under my supervision has we already meet, but for the rest, this may be the first time we meet. Okay, so unfortunately, currently we have to do the online teaching. Okay, we have to proceed with online teaching because the future is still unknown. Okay, we don't know, is it the quarantine will be continue, or will we continue our lecture as face to face after this. But whatever is, the lecture must go on. Okay, so for today I continue with lecture number 6. Okay, so basically Dr. Chang has done his part. Okay, from lecture 1 for introduction until lecture 5. Okay, so this is my first lecture. Okay, it's actually on the overview of CAD. What is CAD, CAM, and CAE? Okay, the most 3 important keywords in this subject. Okay, so first of all, I'm Dr. Zafran from Mechanical Engineering. So this is my email. Okay, so if you have any question after this, maybe you can ask through the e-learning website, or you can directly email to me. Okay, so just to update a little bit on the schedule, maybe you have go through it to from the e-learning. Okay, what Dr. Chang have update in the e-learning website. Okay, so currently we are in week 6. Okay, so week 6 should be, we proceed with our lecture number 6 here. Okay, and actually I only have 2 weeks of lecture. So next week will be a mid-sem break that have been bring forward to week 7. Okay, so week 8 is basically whatever is this. As a VC said, we have continued the lecture as online teaching if we cannot continue as a face-to-face lecture. Okay, so also regarding your proposal, it has been extended to submission in week 8. Okay, it can be submitted as soft copy. Okay, if you still cannot go back to USM, or you still at home, so it's possible to submit as a soft copy. Okay, so for the CATIA practical lab, okay, maybe there's another announcement by Encik Zihad later on how he will conduct the practical class. Okay, so in week 10, basically we have another progress meeting. Maybe during this progress meeting, the supervisor will comment on your proposal. Okay, and then week 11, basically we plan for the test number 1. Actually it's on the conceptual and theory of the CAD. Basically it's only involved for the Dr. Chang and my parts lectures. Okay, maybe we can do it online also. Okay, then later we have another progress meeting in week 12, and also the CATIA Viva. Okay, maybe it can be done online also. Okay, and finally in week 15 there will be a project report and logbook submission. Okay, in worst case condition, maybe you have to submit also by email into a soft copy. Okay, so okay, the first part is on the CAD. Okay, so basically what is the definition of CAD? Okay, it's a computer aided design, okay, or drafting. So you should know it because you already do some CAD design using SolidWorks in your first semester. Okay, so for the second semester it's just the different software and more detailed intro on the theoretical part of the CAD, how you want to create a design concept, okay, also some elements regarding the pattern and etc. Okay, so this means that you are doing your design or drafting with the help of computer. Okay, what is stand for the computer aided design? You mean you design by the aids of the computer, okay, with the help of computer. Okay, so for the CAD, okay, this is the why it's important to do the CAD design. Okay, so by using the CAD, actually is you can provide a very precise and accurate, okay, because you can design your dimension in very detail. Okay, so also you are capable for replicable operations, means that if you have done your design, first design A basically, and maybe you want to do a design B, maybe there's just a little bit changes, so you can copy everything in design A to design B and make the changes, okay, the minor changes. So it no need like a manual, you need to recreate everything, but for the CAD it just can be copy and paste and then you do a modification. So basically in CAD file, mostly of the CAD file is a shareable file, okay, with the other software. For example, how you have done your CATIA, okay, you can save your IGS format file, and later you can also open it in SolidWorks. Oh, and then instead of that, if you want to do some simulation in ANSYS or Abacus software, okay, or you want to send for the manufacturing software, the CAM software, it also can be done. Okay, that's the advantage of why you need to learn CAD. Okay, so nowadays CAD is capable to solve nearly all design process. Okay, so that's this save design time, and this is some of the advantages in terms of this. It helps to reduce the cost, okay, when you save the design timeline, so that you can reduce the total overall project cost. Okay, then you should be able to produce high quality product, of course, because you can produce very accurate design, okay, and some detailed design, so you can also create a very quality product later. So you're also able to improve the product, so any of the advantages you find defect in the products, you can directly modify it using the CAD software and later you can improve the product itself. Okay, so basically in 3D design and in the CAD software, there will be 2D and 3D CAD. Okay, so this is basic, a simple understanding that you should know. The 2D is involve a X and Y axis direction or surface for the modeling, while for 3D is an additional of Z axis direction, so that you can create a more detailed design. Okay, so for the 2D CAD, is appropriate for the products that has easy geometry without the need of consideration or need of considering the interpretation of error. Mean that 2D you can directly design it using the 2D environment with a easy geometry, okay, like a blocks, circle and everything, okay, without any of involve a big error. Okay, so there are pros. What is the advantage of 2D software? 2D CAD is allow design modification and copy of design to be easy. Okay, of course, because you have involve a very simple design, so you can easily copy and modify it. The quality of reproduction of drawing is guaranteed. Okay, so that when you want to send it to the manufacturing, for example, okay, it's easy to be modified and reproduced. Okay, it's a faster process than manual drawing. Okay, of course, you have learned it, you have experienced it in engineering drawing during the first semester. It's very uh, it take times also to you for to do the handwriting drawing, manual drawing, and for the 2D is can get you faster. Okay, so the data can be interpret to the CAM software, of course. Basically in industry, if you want to produce it in production, you have to scan it in terms of 2D drawing, because the production is they are read the software and the drawing into of 2D because they want to know all the detail in an A3 papers, okay? So that's important of that. So there's also the disadvantage of 2D CAD software. Basically, it's hard to ensure that all the components can be actualized in 3D world, so that when you see in one piece of paper of A3, for example, you have a 2D drawing, actually it's very difficult to imagine what is the 3D of the design itself, okay? You need to access the 3D software to see what is the actually in terms of overall view of the design or products. So physical properties like volume, surface area, and center of gravity cannot be determined, of course. Okay, this is can only be determined in 3D solids, 3D solid design. So the detailed product component can be unfold. Okay, it's also difficult to see the detail of the product itself in 2D drawing. So now we go to the 3D CAD. Okay, basically it's also known as a geometry modeling. Okay, there are three methods in 3D modeling. The first one is wireframe modeling, okay, the surface modeling, and also the solid modeling. Basically, this is the also the step of design a solid using the surface environment, where you can draw the wireframe first by point coordinate, okay, and then you create a surface, and later you create a solid, okay. So maybe I can draw you the example, okay. So let's say you have a point, this simple square point, okay. Okay, so like you have a coordinate A, B, C, and D. So wireframe is of course just a continuous line to create this square, okay. And also this maybe another point, okay. Okay, maybe A1, B1, C1, and D1. So later you can create a surface, okay, and if you have the surface of A, B, C, and D, later to make it as a solid, you can just extrude it, okay, in whatever dimension, for example 3 cm, and you can make it as a solid, okay. So that's basically the step of create a solid soft design in CATIA surface modeling, okay. That you will learn later in detail. So this is some detailed explanation what is a wireframe modeling, okay. The shape is represent as a line element, okay. This line element like A to B, B to C, and C to D, okay, that are interrelate and provide accurate information about the edge, okay, the edge of A to B, for example the corner of B here, okay, and the surface discontinuity, okay. You will also know during you want to extrude as a surface from surface to the solid, it will become error if you are not connected properly all the points, okay. It's the easiest type of geometry modeling, of course, okay. Just connection of line between the points, okay. No information about the surface, okay. If there's no surface here, so you just only have a line and a point. Hard to differentiate between the interior and exterior part of the objects. If the object is very complicated, just in terms of wireframe, it's very difficult to see what is the to view in terms of what is exterior and where is the exterior and what is the where is the interior part, okay. Okay, some notes here. This is why this type of modeling cannot provide a correct interpretation about the complex objects, yeah. usually it strongly depend on the user self interpretation. Okay, you must have a very high imagination to know the detail of the drawing. So this is some of example of how the wireframe modeling. Okay, you can see like this jet fighter is very difficult to see where is the interior and exterior parts, also the body car surface and this ship design. Okay, so basically this is a drawing that drawn by the wireframe. Okay, so the second part is the surface modeling. Okay, it show the exterior of the geometry basically. Okay, so we go back to our design here. Okay, when we have this off shape A B C D and we make it a surface. Okay, it represent the object but only shows the exterior skin of the object. Okay, the advantage of the surface modeling is allows for the cross section area to be done by feasibility study. For example, to design the mounting concept between the bumper and the car body panel, or the airplane exterior surface and internal cockpit mounting. So I show you the example. Okay, based on my experience. Before this, I'm working with automotive company. Okay, so let's say you have a surface here of the bumper. Okay, so okay, this is the hood. Okay, the front hood, and maybe this is a bumper. Okay, so this is basically the surface, external surface, and maybe this is the internal panel, okay, of the car. Okay, maybe this is you can extend, this is the tire part maybe. Okay, just a simple mounting. Okay, so from this, okay, we as an engineer, we are more on the detail on the internal part. So basically the external part, this is the external, the surface, and this is the internal part. Okay, so we are engineer, basically we are thinking of how this bumper can be mounted to this structure. Okay, using a mounting, whatever of anything mounting concept here. Okay, okay, so basically the exterior part, the surface body part is not designed by engineer, it's designed by surfacing. Okay, surfacer we call it. They are more on the arts person, and we are design engineer, we are more tackle on the problem on how it can be mounted to the body structure. Okay, this is an example of the advantage for the surface modeling. Before we want to create a solid, it can be used as a cross section to design the detailed mounting concept, for example. Okay, so this is an example of surface modeling. Okay, the jet fighter. Okay, you only know the external parts. Okay, the body car panel, also the vase. Okay, by the surfacing. Okay, we go to the our last part of the model. This is on the solid. Okay, is provide information about the topology of the object, where you can determine the volume, the mass, and also the exterior part. Okay, it's allow for the detailed cross section area to be done on the complex model to show the interior part in detail. This is an example that I have drawn you before. The car body panel that can be designed detailed by from the surface to the solid. Okay, so the kinematic action also for the moving components can be studied in 3D. Okay, so let's say you have designed the hood. Okay, so you can know when it's open condition. Okay, the angle, is it when you close it, is it have the interfere here. Okay, for example, this all can be done by in solids environment. Okay, so the physical properties like the mass, the moment of inertia, center of gravity can be easily calculated and determined using the CATIA or SolidWorks software. The drawing can be done fast and accurately, and in the most solid modeling, the parameter relationship is connected between the dimension. Okay, to help for the ease modification and assemble. So when is everything in solids, Okay, if you want to change the dimension, for example, it have a reference point, so when you change one part, the other parts will follows. Okay, so that is the advantage. So this is some of the detailed design of the engine when it's become solid. Okay, the gun, so the camera. Okay, this is the to show you the comparison between the surface and the solid before it becomes solid. The surfacing area is in yellow color, and when it becomes it becomes solid, it become a gray color. Okay, so we go to the next uh, the next step study is on the cam. Okay, so the cam is computer aided manufacturing, which mean that with the help of computer you can manufacture something. Okay, so basically the cam software is built in this CNC machine, computer numerical control machine. Okay, okay, where you can just do the manufacturing process or to produce the product using this control panel that's built in by the CAM software. Okay, so why CAM? CAM can ease the process of manufacturing the products from one step to another step. Okay, you can design by G code from one first step, maybe to complete the design of simple cylinder. For example, it involve for example a 50 step of process. So by using the cam you can design you can each of the step for the manufacturing. Okay, and also it's all for any modification of the final design based on the CNC. So you by the simulating the CAM software, you can know what is the error that can be determined before it goes to the real production. Okay, maybe we can have the video here to show you detail on how the this CAM software works. Okay, this is basically the G code. Okay, all the simulation, the movement of the machines. Okay, is followed by the G codes. Okay, so this is the simulated by the CAM software on how you can simulate first. Okay, based on the real CNC, so that you can determine the error, what is the error, and then you can improve it later. Okay, so this is example of the collision, the error that you have to improve, and then you can modify the G codes so that you can eliminate this error. Okay, okay, so there's no collision anymore. Okay, Okay, so that's basically you can see in detail later until the end of the process. But what I want to highlight, there's a very powerful software that you can simulate first. You can determine the error before you go to the real production of your products. Okay, so our next item is on the CAE, okay, computer aided engineering. Okay, this is a simulation software, okay, that you can before you can after you design, you can do the CAE first. Okay, you can simulate to determine the stress, for example, the weak point of the your products, so that before you go to the CAM software, okay, before you go to the real manufacturing of your products, okay, so that you can eliminate the weak point of your uh, uh, design. Okay, so basically the two famous software currently in this world is ANSYS and Abacus software, but in USM we are more focusing on using the ANSYS software. Maybe you can experience it during your third or final year for your final year projects. Okay, maybe your supervisor asks you to do some simulation using the ANSYS software. Okay, so why CAE? Okay, actually CAE can translate the CAD model into the manufacturing instruction for the CNC machine. Means that you can do some simulation first, okay, so that is benefit for the instruction at the manufacturing CNC machine. Okay, that's based on what I have said before. When there's some stress, okay, some weak point of your products, you can improve it, or you can do some of instruction for the CAM software to improve that area. Okay, so you can do analysis in terms of stress, vibration, thermal, flow, etc. Okay, so I want to show you one example when you can do the vibration study using this software. Okay, so this is study on the vibration, how you study the modes. Okay, the bending modes, the first bending modes. Okay, this is during the static condition. When they study the vibration, they will determine the natural frequency, okay, and also the how it uh, the movement of the vibration. Okay, for example, okay, this one, okay, maybe I can show you one of this example after this. Okay, the 7 mode, for example, it at 75.7 hertz of vibration at these frequencies. Okay, so basically at the frequency there will be the movement of the structure. Okay, so when you have designed this Excel, for example, and there's a vibration at that value of 77, so this the how the structure will work, will move. Okay, the movement of the structure. Okay, there is some of the importance so that you will know the weakest point like this. Okay, when it bend like this, it become red, so the very high stress and vibration there. Okay, so is that's the some important point, okay, or knowledge that you can get from this software simulation. Okay, this is the overall cycle of how you want to from the design until the manufacturing of the product. The first, you use the CAD software, for example SolidWorks or CATIA, to design, okay, your products and do some of specification in dimension, for example type of materials. And finally you can do some critical quality parameters check. Okay, a simple simulation using SolidWorks. Okay, before you transfer the data to the CAE software like Abacus or ANSYS, where you can do a detailed analysis in terms of finite element analysis, failure analysis, stress, and also durability. So from this analysis, you can further improve your design, and then you try to simulate back until you get a most perfect design before you send it to the CAM software for the manufacturing. Okay, for the process of manufacturing, you can simulate first, like the video that I have shown before. Okay, you can do the manufacturing process analysis. Okay, you can determine the collision and everything. Okay, the Six Sigma, lean manufacturing. Okay, so the Six Sigma is more focused on the achieving consistent results, so that you want to avoid any defects such as the collision and everything. The lean focus on the analyzing the workflow to reduce the cycle time and eliminate the waste, so that you can do some lean analysis also using the CAM software, so that you can produce the product in the shortest time, so that you will reduce the cost and everything. Okay. Okay, so the next one is to show the overall step. Okay, so this will also benefit for your project design. So basically, the first thing that I ask for your proposal is to get a feedback from your friend. Okay, by using the Google form, you can question whatever your product is important to design that product that is based on the customer requirement. So if there is positive feedback, so that you know there's a market there and that you can produce your product. Okay, because they high demand. Okay, so you go to the conceptual design. This is the stage and you can use by your hand sketching what also that has been asked before, and then you can proceed with your AutoCAD or, or just a sketching. And then when you finalize your conceptual design, you can move to your 3D software, where there's a list of you can using the ProE, CATIA, SolidWorks or NX CAD software to create a detailed 3D design. Okay, so for this subject, actually we are until this stage only. Okay, so if you are going further later, maybe you learn in your second, third or final year subject, and you go through the analysis using the CAE. Okay, the ANSYS. Okay, Nastran, Hypermatch or Abacus, for example, that you can determine the vibration, stress, durability and everything. And finally, you go a detailed drafting and detailing of the 2D drawing before you go send your drawing to for the final manufacturing. So this is the another software that used for the planning and management for the overall step of the projects. Okay, maybe it can be used as a Primavera or MSP. This is on the more on management software that most of the industry that use. Okay, to produce the products. Okay. Okay, so the next one, just to list you the some of the software for the CAD and CAM tools. I have list some of the available software in this world that available, but in USM we are more focusing on the SolidWorks and CATIA software. That is the two license that we have here, so that we are focusing on this. And most of industry nowadays also uh, uh, using the same software. Okay, for the aerospace and automotive industry, for example, the CATIA is the most important part, because they are surface modeling. Okay, the surface is a very powerful software. Okay, there's a required uh, high demand in automotive and aerospace engineering industry. Okay, so for the CAE tools, okay, there's also some of the software. Okay, but in USM we are more focusing and we are uh, doing the analysis using the NC software. Okay, there's also some kinematic or dynamic study software here. Okay, you can explore later. And for the detail fluid dynamics calculation also, okay, you can use a fluid for aerospace. Okay, and also the plastic molding analysis. Okay, mold flow, and finally some electronic packaging analysis also. Okay, so I think that's all for today. Okay, I hope you enjoy the class. Okay, if you have any question, you can always ask me using the email or the e-learning website. Okay, thank you very much. Enjoy your class. Thank you.